Welcome back to the course Fluid Mechanics. Let's continue discussing the other concepts in the fundamental properties of fluids. The next property is specific gravity denoted by S. This is the ratio of the unit weight of a fluid to the unit weight of water. The computation can also use density instead of unit weight. Water is considered a universal fluid, thus, it is used as the reference for specific gravity. In formula, S can be omega of fluid over omega of water, or the fluid's density over that of water raw. Taking into account that specific gravity is a ratio, it would be unitless. Because we are going to use unit weight or density of water as reference, it would be worth noting that the unit weight of water is 9,810 newtons per cubic meter in SI units, or 62.4 pounds per cubic feet in English units. Similarly, mass density of water is given as 1,000 kilograms per cubic meters in SI, or 1.94 slugs per cubic feet in English units. Let us consider some examples. What is the specific gravity of gasoline when its raw is given as 680 kilograms per cubic meter? In this problem, specific gravity would be asked in terms of its given mass density or raw. Thus, our formula would be specific gravity is equal to density of gasoline all over density of water. And plugging our values, 680 kilograms per cubic meter all over 1,000 kilograms per cubic meter would give us a specific gravity of gasoline as 0.68. The other example says, what is the unit weight of seawater when its specific gravity is given as S is equal to 1.025? In this example, what we are asked would be its unit weight, thus our formula for specific gravity S would be taken as omega of seawater with that omega of freshwater. Plugging our values, 1.025 is equal to omega of seawater all over 9,810 newtons per cubic meter, giving us the value for unit weight of seawater as 10,055.25 newtons per cubic meter. Taking our third example, ammonia with specific gravity of 0.608 fills a 0.2 meter diameter by 1 meter vessel. How heavy is the fluid inside the tank? For this problem, are we going to use mass density raw, or would it be unit weight for our specific gravity? Try to check that our required is in newtons, which would be derived from unit weight. Thus, our formula for specific gravity would be taken as that of unit weight, which would be unit weight of ammonia all over unit weight of water. If we are going to plug in our values, 0.608 for specific gravity and 9,810 newtons per cubic meter for our unit weight of fresh water, and by cross-multiplying these values would give us the unit weight of ammonia, which is 5,964.48 newton per cubic meter. Note that this is the unit weight and not yet the weight of our ammonia or the fluid inside the tank. But we know that unit weight would be equal to weight of ammonia all over the volume of the vessel. Thus, if we are going to have them cross-multiplied, our weight of ammonia would be that of the unit weight, 5,964.48 newtons per cubic meter, times the volume of ammonia, wherein our vessel would give us the volume of pi all over 4 times 0.2 meters squared, or that would be the area, and 1 meter length, which would give us our value for the weight of ammonia as 187.38 newtons. The fourth fluid property is viscosity, and it is designated with the symbol mu. Just what is this property? Checking on where the word comes from, this hails from the Latin root viscum, which means sticky. So this property can be described as the one which measures the fluid's resistance to flow. Sometimes this is called dynamic viscosity. Upon checking with this video, you would notice that fluids do have different viscosities. The difference in fluid viscosities would let us use different forces, which means that if you are going to check on less viscous fluids, which we call low viscosity fluids, they would require a smaller force compared to more viscous fluids, which we would also call high viscosity fluids with a bigger force. So why is viscosity important? This property can tell us how much time a reservoir will be filled or how much time it will take to release water from it. Another will be how much power should a pump have to raise a certain fluid, and understanding the resistance of the body when being injected with certain fluids. The formula involving viscosity is given with the stress format where tau is equal to mu times the shear rate given in derivatives. Note that tau is the shear stress, which is equal to force all over area, mu would be viscosity, and dV all over dy would be the shear rate. A subtype of viscosity is what we call kinematic viscosity with the symbol nu. This is taken as the ratio of the dynamic viscosity to its mass density, or nu is equal to mu all over rho. In English units, nu is taken as square feet over second, and in SI units, this would be taken as Stokes or square centimeters per second. Hang on tight for you to check on surface tension and capillary action.